Now to convert a partial differential equation to its canonical form, what we will do, we will make some changes in the independent variable space. Now suppose this sorry, just give me a minute here. So suppose we were to solve this partial differential equation, and actually we were on the plane x, y and u this side. Now what we will do, we will actually change the independent variables, say to some value, say xylon and eta, and this xylon and eta are actually depending on x and y, and we will try to now reconstruct the whole differential equation of u and solve that u. Okay, now we cannot change from any from the xy to any of xylon eta space. To do that, what we have to do, we have to check that this xylon and eta must be continuously differentiable, and the Jacobian of them, that is del xylon eta del x y, that is the Jacobian xylon x xylon y eta x eta y, where these suffixes are they do mean that you are taking the partial differential equation with that particular suffix sign, and this should not be equal to 0. Okay, so this is the condition in the whole domain of the solution. Now so we are changing from xy space to xylon eta space, so our differentiation signs will be changed, like see ux, this is del u del x, we will convert the differentiation in with respect to eta and xi, so this will be written as u xi xi x u eta eta x. If I write more explicitly, this looks like del u del xi del x del u del eta del x. Now a point to be noted that just simplicity, we will not write that whole, and we will simply write with using the suffixes. Now u y, this is u xi y, u eta y. Now towards the second order differentiations, uxx. Now uxx actually is follow that this is del x of u xi x u eta x, right? And so actually this turns to be, see, xi x del xi, actually xylon, actually this xi x u eta x, right, plus eta x del eta u xi x u eta x, and we will open this two parentheses, and we will have u xi x square plus, see, from here one u eta xi will become, and from here another eta xi will become, so this will be 2 u eta xi x eta x plus u eta x square plus u xi x u eta eta xx, right? Can you see the whole as a, so this is the form, right? And now for uyy, actually for uyy you can see the same logic will be done, only here this formula should be written in this parenthesis, and this differentiation should be with respect to y. So for by a simple calculation we can write u xi x xi y square 2 u eta xi this plus u eta y square plus u xi yy plus u eta yy, and lastly u xy. Now for u xy the same thing can be done, just write y there, right? Because actually you are differentiating ux with respect to y, simply that. So and the result becomes u xi y square 2 u eta xi sorry, I'm not 2, I mean I'm very sorry, and this is x, and eta xi you can take a common, and then first term will be this, and the second term coming from the second parenthesis, and u eta x eta y plus eta xy plus u eta xy. So we have converted all these differentiations with respect to y, and I mean not with respect to x and y. Now we have written all the things with respect to eta and xi. Now we can incorporate the whole part in the given partial differential equation, that is in this equation. Sorry, actually in this equation. And doing so, what we will get, simplifying, you can write the whole part as a bar u xi, b bar u xi eta, c bar u eta, d bar u xylon, e bar u eta plus f bar u is equal to g bar. And where, I mean this ABC you can calculate, and you can check that a bar is a xi x square, b xi x xi y, c xi y square, b 2a xi x eta x, b eta x like that xi y eta x plus 2c eta y xi y. C bar is equal to a eta x square, b eta x eta y, c eta y square, d is equal to a xx, b is xy, c xi yy, d xi x, e xi y. E bar is equal to A xi xx beta xi y xy, sorry, C eta yy d eta x e eta y. F bar is equal to f itself and g bar is equal to g itself. So what we have to do, we will take the transformations in such a way, the coefficient such a way such that the coefficients, we can remain with this primary parts only. So how we will change those equations and those coefficients, that we will check laterly, in the next lecture, that what extra incorporation will help us to determine some simpler equations, or that some simpler A bar, B bar and C bar, etc.